All right. I think that does the things we need it to for all of the things that we need. Now, what else do we need? We need some Discord action. We do, we need it. We need the Discord action. The Discord action is just more of the same, of course. HTTP URL, 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 publish, confirm, and another Discord, streams channel, there it is. What do we got here? More of this. I'm 16. No, how many days am I behind? I'm 9 days behind, I think. There we go. That is posted. That is posted. And we got some ads going on, which is cool. And we do this. And it works. We do this. And it works. Small Block Boy. Good on them. Streaming away. We got Whitechapel. We got Bad Cops on. We got Year End. Hypnotic. And Luke Wolf Games is here. Aonema. Huh. Do I know that name? Oh, and Adagon's on. PG Komai's on. Sweet. All right. And we may as well do like we should do we should do a, what do you call it? What's the name of that service? Blue Sky. We should do a Blue Sky post. Blue Sky. Blue Sky. Blue Sky. Oh, I'm not even signed in on that service. What? Let's sign in. Invalid identifier or password. Really? That doesn't seem likely. Oh, that is not my one password. That is something else entirely. Let's check this and see what's going on. Blue Sky. Which Blue Sky is that? That is a different Blue Sky. Copy. See if this password is different. Hey, it is. Yes, it is. Is there anything suspicious that I can't put on screen? No, there isn't. Cool. All right, Blue Sky. The new thread replies here on Blue Sky. Great, so much nicer. Go turn them on. Oh, okay. Settings. Content. Thread preferences. Show replies in a threaded view. Sweet. Sounds good. Do I have to save? No. Fair enough. Plus that up a little. And let's see here. So I don't know Blue Sky very well. We make a post. Hello. I streaming. We streaming. In fact, we streaming. Still working through the AOS advent. Wait, is it a hashtag? Advent of code? Maybe. Maybe it is. And Rust with a little bevy engine sprinkle around the edges. Does a call to debug to print the answer from a bevy system count as using bevy? Cool. Thought so. Twitch TV Basie. Hey, it's a Blue Sky post. I do not make many Blue Sky posts. All right, sweet. I don't even have one of these things, one of these flash things here. I don't even have it. What are they called? Banners. I don't have a banner. I should make a banner. How could I make a banner? Account. Appearance? Oh well, we'll do it later. We will do it later. Okay, so we're up to day 9. Wait, where's my tea bag? It has disappeared. Aha. The tea is essential. The tea is life. Okay. So we solved the thing with the antennae and antinodes. We figured that one out. And I've also decided that for part 2s, oh yeah, I should look at Chris's solution too to see what I did wrong. I'll do that in a sec. I've decided that for part 2s especially, I'm going to treat them as learning experiences. So if I need a hint, I'm just going to get a hint. Like I'm not going to be stubborn and struggle for hours and hours and hours because it's not a useful experience. So I'm just going to kind of try and get through as much as I can. And like I did yesterday, I was fine. But if it's going to take hours and hours, then it's fine to go and see what someone's approach was, even just the beginning of it, so that I can understand what the idea is, and then implement it myself. Maybe even in another language. Okay, so actually, let's do Chris's Chris Biscardi. I hope I'm pronouncing that right. Who we will shout out right here as an excellent YouTube channel where he talks about all things Rust and Bevy and content creation in general. Highly recommended, and runs a Discord as well where there's a bunch of people doing Advent of Code. So videos, we're looking for day 8 now that we've finished it. And I'll just skim through this. I don't want to restream his entire video, but just so that we understand.
Alrighty, welcome back. Advent of Code, day 8. You find yourselves on the roof of the top secret Easter Bunny installation. You know, sometimes the Advent of Code lore really slaps. A familiar huge antenna, reconfigured to emit a signal. Each antenna is tuned to a specific frequency indicated by a single lowercase letter, uppercase letter, or digit. We've got a map of the antennas, antinodes based on resonant frequencies.
Sometimes it's interesting to see exactly where how quickly people pick up on what they need to do. Like, I'm pretty sure I was able to look at it and go, okay, this is probably a vec2, right? Because it's got a height, it's got an x and a y. So you can do the distance between two vec2s.
Point that is perfectly in line with two antennas of the same frequency, but only when one of the antennas is twice as far away from the other. This means that for any pair of antennas with the same frequency, there are two antinodes, one on either side of them. Any point perfectly in line with two antennas of the same frequency. So for these two antennas with frequency A, they create the two antinodes marked with a hash because they are diagonally in a line. Oh, that's unfortunate. Adding a third antenna with the same frequency creates several more antinodes.
Okay.
It would ideally add four, but two are off. So this is 1, 0, 1, 2, 3, 0, 1,
Yeah,
2,
that's what I was
3,
doing.
4, 5, 0, 1,
Counting it
2,
out
3,
manually.
4, 5, 3, 4, and 5, 5 gives -2, 1. Or I guess that could give -2, -1. Sorry, it's -1, -2 because it's 4, 3, 5, 5. So -1, -2. So that would be 3, 1 if we add them. 0, 1, 2, 3, and then 0, 1. That works. And 5, 5, we need to invert it, which would give us the other one. So if we do A minus B, then it's A plus the result and B minus the result to get the two other points. And then we can just kind of keep those around, cut off the ones that are outside the map, maybe add them to a set because we might have multiple. So 1, 2, 3, 4, 5, 6.
Yeah,
Antinodes
I
can
ended up
occur at
using hash
locations
set
that
as
contain
well. Okay,
antennas.
let's skip
Can the
ahead a little
map
bit.
bounds? We need to get all of these locations. Our
Yeah.
test input doesn't have any of them next to each other, but our real input definitely does. So we have to make sure that we parse these individually because they're
Sure.
not a satellite called US. It is a satellite called U next to a satellite called S. Luckily, we
Absolutely.
have a parser from NOM for
Oh, I still
alphanumeric
use
1.
nom. That's
This
interesting.
would
I
give,
didn't I
I
didn't
think,
go there that
too
time.
many in a row, though, because this would
Okay,
just
I
keep
don't,
chomping
I'll
at them.
just
The
skip
as
ahead through
car
that.
trait from NOM, which provides that function. You can see the trait here. It's got as car
Oh, cool.
is
So
alpha
you can just
num,
take one
and a couple of other things.
character.
And then we've
Nice.
got this parser called satisfy, which takes a closure and allows us to take the character here and test to see if it's the thing we want to parse. In
Oh,
this
nice.
case, all of our satellites are going to be
Interesting name.
characters,
Satisfy.
and or we replace the input type with this new span input type, which is basically a container around the string slices we were using before. That allows us to create this other parser that also takes a span, which I broke out for clarity purposes. We get the position that the input is currently at. We get the column and the location line, so the column and the line that we're on. And then we have our parser from before exactly as was, which gives us our character, and then we return everything. And that
Okay.
gives us a bunch of locations. So we should do a little
Yeah.
bit of checking and make sure
And
that our
he's
math
using
is correct.
iVec2 like
So
I did. Great.
0, 1, 0,
I'm
1,
quite sure
2,
what the
3,
zero.
4, 5, 6,
Oh,
7,
okay.
8. 8, 1 is in fact a 0. And then
Oh,
0,
I
1,
see. Yeah,
2,
sure.
0, 1, 2,
That's
3, 4,
much,
5,
much like
also
what I did.
correct. Actual order
Okay,
doesn't
cool.
matter. All that matters is that they are all next to each other. And if we look for something like chunks, in this case, I'm not decided yet. I think since we're mapping over all of this stuff, we might actually end up with the count from this iterator anyway. I haven't really made that decision yet. So if we did something like count here, then we have our chunk. We're mapping over the slices. Tuple windows gives us each tuple. We have position A, position B. In this case, I have a unit here. So we could have like A minus B here or something like that, right? And if we had count, then we would have a vec
I
of U
think I'm going to
size.
skip to the
And if we
part
look at
one
all these, we're
recap
kind of
here.
seeing all change the rules. Got it. Okay, so what did we do here? We did a cool little bit of parsing today. So we started off with nom,
Yeah,
right?
that
And we
was
wrote
interesting.
our parser to get the things that we needed parsed in the first place. That was the satisfy here with interesting things about dealing with failure in nom.
Still
Some parts
passing.
that, in this case, I did it fairly verbosely. And then we return our IVEC2 with the car here. And that gives us a vec of IVEC2s, which is all the positions information that we got from nom locate and that
Gotcha.
car that are O's, etc., into this chunk here, which you can see is a slice of IVAC car tuples. Now we do flat map here because we're going to create nested data inside of this. When we
Oh,
return something like this, that is an array that has multiple values from inside an iterator, that means we have that
I
extra
just used
kind
a hash
of
map.
array inside an array sort of deal. And if we flat map, that removes this outer.
So what I ended up doing was, where are we? On main and source. Where is it? Days. Day 8. Where's my day 8? Okay. Apparently I didn't push it. Did I not push it? Oh, apparently I didn't. I thought I did. Oh no, this is the stuff for day. It's unpushed. Gotcha. That'll do the trick. Oh, what do you mean it rejected? What? What refs don't I have locally? What changes did I make? Huh. Okay. Apparently I didn't update my copy of day 7 on here. There we go. Now we should have day 8. In theory. There we go. Okay, so what did I do? I did yeah, I did a hash map of antennae because I wanted them indexed by the character just to make it easy. And so you end up with a hash map of character and then a vec of locations, IVEC2s. Just put that in there. And let's see what else happened.
Array and flattens all of the results for this iterator, even though we're returning multiple items. So flat map takes each of the chunks for
It's
each of
got
the
2 flat
satellites.
maps.
So this is each satellite chunk. And we're going to iterate over those and produce multiple values. So we flatten those multiple values into a single iterator, which we are later going to do a dot unique and a dot count of the uniques. Now, for
Okay.
each satellite chunk, we iterate over that and pair all of them up using combinations. So if you've got ABC, then you've got AB, AC, and BC. We flat map over those again, because again, we're going to create this nested data structure that we want to flatten out. This allows us to return multiple values from, mapping over an item in our iterator. For our difference, we thought about the math earlier. We have to get the satellite minus the other satellite. These are vectors. So we can do vector math here, which means that we're basically taking this IVEC2 of an X and a Y position and subtracting it here. This is component Y, so it's X minus X, Y minus Y. And that gives us this diff, which is an IVEC2. Add that diff to the left-hand side, and we subtract
I think you
that
can
diff
just
from the
subtract
right-hand side,
IVEC2s,
because we need to flip the sign, right? If we have 2 satellites, like this 0 and this 0, then this has to reach out to here, and this one has to reach out to here. So we have to push them in opposite.
No, I just did where is it? So the distance is b minus a, and this is just subtraction with IVEC2s. And then I subtracted distance from antinode A and added distance to antinode B. And kind of worked out. But that's leaning on the IVEC2, I guess.
Opposite directions, which means we need to negate the sign. And finally, we make sure that they're within the bounds, which actually we don't need to do in here. So if this looks simpler to you for some reason, you can also do it like this. And just proving that that's true. Cool. See, we also get 295. So we don't need to do the filtering here. We just need to do this mapping of the chunks into the satellite diff positions for the potential whatever. It's not.
What did I do? I think I used a hash set for that one so that I didn't have to care about. Oh no, I still had to do bounds checking, so I did that using an irect, and then yeah, just used a hash set so that I didn't have to care about duplicate locations. Yeah. Okay, so it's nice to know I wasn't straying too far from the path.
Anti-chamber, it's anti-node. I forget what they're called. The anti-node position. Yeah. Because these are all going to be the same thing, right? They're all going to just be iterators of IVEC2s at the end. We can put this filter anywhere we want. So for part 2, watching over your shoulder as you work, one of the historians asked you if you took the effects of resonant harmonics into your calculations. So the antinode occurs at any grid position exactly in line. They are out of bounds. So there's a couple of lesser known iterator tools.
Now we're getting into iter tools again. Cool.
So this is the module standard iter in the Rust docs. If we go all the way down to the bottom, we see a number of functions. We've got
So
from
not auditors.
function, repeat, successors, and some other ones. So I think successors is actually what we want here, because if we do
Oh,
successors, this allows us to start with some value, so the satellite
what?
position, and then apply some value to that position and produce
Yeah.
a new value. So I think actually, now that I think about it, the first item is going to get included in the successors. So we probably want to try to remove that somehow, but we'll
Huh.
get started with successors and we'll kind of work it
Oh,
forward
that's
from
really
there.
interesting.
Right. So if we have a successors with the satellite location, this is our position and this is position plus diff, right? This should just create that whole chain. Now, one of the issues here is we do need to get rid of that first iteration if we do this. So if we do let mute first here, first dot next should give us that first value, which we want to throw away. So we won't do anything with it.
Sure.
Or we can even do like let underscore equals first dot next and do
Yeah.
something like discard first value. Our other option is to stick that calculation in here and out there. And then next would give us just the next one, and so on and so forth. Now, this will just be an infinite iterator. We do need to bring
Got to
successors
break
into
it some
scope
with a
at
bounce
the
check.
top. We do need to make sure that our math lines up here. So here we have the return value sum. If we return none here, then we won't actually return a value. So let's do
Oh,
this check again. New
yeah.
position
Bounce check.
equals position plus diff if x bound
Okay, let's
contains
skip
that and
ahead
y
to the
bound. This is the right
to
answer.
the
That is
summary.
the right answer. Let's do a cargo bench today since I'm
Oh, yeah.
feeling reasonably good. The other one was just kind of a introduction. And we talked a little bit about how to kind of shortcut this potential issue with these
Successes is
iterators. So
interesting.
if we did no collection here, for
Today I
example,
learned.
and we tried to return these and we tried to run this, we end up with, well, first of all, we typed the first results as a vec, so it's no longer a vec. That's an issue. But the second result is a successors. So let's get rid of this type here. So we theoretically have successors going in one direction, successors going in another, and then we've got first results and second results that we're returning, which are
Huh.
both iterators. This error is expected closure found different closure. That's because closures don't
What?
have the same types, even if they seem to be identical. The
Oh,
suggestion
okay.
is consider boxing your closure and or using it as a trade object. And to
Oh,
some extent, if we
that seems a
box the
little
closures,
complicated.
it kind of helps. We then need some annotations. But even at the end of the day, and we
Big
box
discussion
these
on
like
returning
that,
arrays. Okay, interesting. All right. Thank you very much, Chris. Have a like. Uh, tail and successes. Um, I mentally substituted antenna for satellite. Yeah, exactly. Okay. Type safe way to create the combinations. Tuple combinations flat map A, B. Interesting. Tuple combinations. Okay. All right. Nice. So back to day 9. I've already done my setup for day 9, so I think we're good to go. So disk fragmenter. Another push of the button leaves you in the familiar hallways of some from friendly amphipods. Good thing you each somehow got your own personal mini submarine. The historians jet away in search of the chief, mostly by driving directly into walls. Nice. While the historians quickly figure out how to pilot these things, you notice an amphipod in the corner struggling with his computer. He's trying to make more contiguous free space by compacting all of the files, but his program isn't working. You offer to help. He shows you the disk map, your puzzle input he's already generated. For example, blah, blah, blah. And we've put that in our test. Ta-da! We'll get Rust Analyzer warmed up while we read the rest of this. Okay, sweet. The disk map uses a dense format to represent the layout of files and free space on the disk. Cool. The digits alternate between indicating the length of a file and the length of free space. So a disk map like 1, 2, 3, 4, 5 would represent a 1 block file, 2 blocks of free space, 3 block file. Oh, I see. 4, and then a 5 block. So every single digit. Right. A disk map like 90909 would represent 3 9-block files in a row with no free space between them. And just for reference, the actual puzzle input is 20,000 characters long. That's a big line. Cool. All right. Each file on disk has an ID number based on the order of the files as they appear before they are rearranged, starting with 0. I see. So the disk map 1, 2, 3, 4, 5 has 3 files: a 1-block file with ID 0, a 3-block file with ID 1. I see. So just a normal incrementing ID. Using 1 character for each block where digits are the file ID and dot is free space, the disk map 1, 2, 3, 4, 5 represents these individual blocks. O dot dot 1, 1, 1 dot 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 2, 2, 2, 2, 2. All right. The first example above represents 3 individual blocks. These individual blocks. Okay. So 2, 3. 1. I see. These are the IDs. All right. I think I'm picking up what they're putting down. Why is there no free space here? Oh, because 0. Ah, 0 is special. All right. The amphipod would like to move file blocks one at a time from the end of the disk to the leftmost free space block until there are no gaps remaining between file blocks. For the disk map 1, 2, 3, 4, 5, the process looks like this. That's the way it starts. Then we move file 2. Wait a minute. Oh, file blocks. So file 2 has file size 5, and we're moving blocks of it one at a time. So you don't have to keep the whole file together. This is, after all, called a disk fragmenter, not a disk defragmenter. So 2 gets moved to the first bit. This 2 gets moved to the second bit. This 2 to there, to there, to there, and so on. Okay, cool. The first example requires a few more steps. Wait, so which is our test example? I see. Okay. So we take the 9s and we move them. We take the 8s and we move them, and so on. The final step of this file compacting process is to update the file system checksum. To calculate the checksum, add up the result of multiplying each of these blocks' position with the file ID number it contains. The leftmost block is in position O. If a block contains free space, skip it. Continuing the first example, the first few blocks position multiplied by its file ID number are O times O is 0, 1 times O is 0. I see. The checksum is 1928, and that's my puzzle, my first test input answer, which I have got in there already. Okay. Compact the amphipod's hard drive using the process he requested. What is the resulting file system checksum? Be careful copy pasting the input for this puzzle. It is a single very long line. Yeah. Yes, it is. You are correct. Okay, so um, good. I don't think I'm going to use the parser. It'll be interesting to see if Chris ends up using nom because that'll be good learning for me. But I don't think I'm going to do that. I think I'm just going to do a character by character process. And we're going to chuck it into we need to retain order. That's very important. So we're going to translate it into, what should we do? How should we approach this? We need to retain the index of each block, which basically maps to a vec, right? We maintain the index of each block and store either the file ID that it contains. Like we could use just options, right? Like it either has a file in it or not. And then it becomes either some file ID or none. And if it's none, it's this. And we just fill it with either some or none until we get to the end. And then we can replace the first sum with something from the end and then return and so on. This could get really slow if you're doing in-place modifications. I'm sure there's a way to use iterators though. Okay, let's have a think about this. I think we're ready to start. So let's go with, we're just doing chars collect on these. That's fine. I don't believe it's necessary for me to convert those to integers. Wait, yes it is, because I've got to add them up at the end. Ha! Or wait, what do I have to add up? I have to multiply. I've got to get the file ID of each one, but I don't have to care about what's stored in it. Or do I? Because part 2 will want to know. So what is the first thing? The length of the file. Oh, the length of the file. So actually all I have to do is store the file ID. I don't have to store the length of the file. Okay. I think this is okay. As long as we always store the file ID, we should be fine. So it goes file ID, amount of free space, file ID, amount of free space. Okay. I think I've got that straight in my head. I believe I have that straight in my head. Okay. Let's try it. Let's try starting to process these things. So we're going to need, we'll go with fn, I guess get structure, get initial structure. Might not be a great name. Let's just roll with it anyway. And we're going to pass it in and char, I do believe. Unless I'm wildly mistaken. Oh, what is the thing called? The disk map. and it's going to return a vec I32. No, a vec option I32. Yes, that is correct. All right, cool. And it's going to return a Miette result for that because that's what we're doing at the moment. Okay. So now we can go with, okay, I don't think we can do that. No, we cannot. We need to go into, yes. Just out of curiosity, can I do this? No. Okay, good to know. Good to know. Now, that'll get us started. So we're going to go with, oh, we need to get our test running too. So we're in AOC and we go bacon test. Beautiful. That's better. And we'll open up a little more space here. Could just not use the mouse like a sensible person, but no, I have to be that way. All right, so chars collect, and then we go let. So what is this? What are we generating here? We've got a disk map, and we're generating file block, file block diagram, file file blocks, file blocks equals, and we'll rename this function to get file blocks with and input question mark and get file blocks. There we go. All right, sweet. So file blocks should be a vec option I32. Nice. So this becomes, this feels like it's easy, but it's probably not because I'm not that lucky. For C in, wait, is this, do I need to know what position they're in? No, I don't think so. For C in disk map, probably iter. And we need a let blocks equals, this is a vec of option of I32. Oh, wait, there's no numbers. Yeah, it's definitely I32, right? There's no negative numbers, so it's probably U32. To be honest, it's probably U16. What do we need to fit in 0 to 9 in? Very little. Let's go U32 for the hell of it. Equals vec. And what is your problem? Oh, whoops. There we go. That's a little better. What's your problem? That is not an array. You're absolutely right. You are absolutely 100% correct. Okay. Now then, we got, we need it to be every other. So should we do it in pairs? Should we do pairs? Should we get pairs of things? So that for each pair, the first one is the file block and the second one, the first one is the file size and the second one is the or we could just do if I %2 is 0, right? Oh, hey, Eldon. How you doing? What, am I mispronouncing your name? No, definitely Eldon. It's going good so far. It's interesting. I was pleasantly surprised that I managed to finish day 8 yesterday, so we're just cracking on. We're cracking on. We're only 8, 7 days behind everybody else. It's only a week. What's a week between friends? Okay, so I feel like we're definitely going to need enumerate. So I see and this map. Part 1 so far. Yep. Escher enumerate. Okay. And then basically we're going to say if now how many, yeah, so if it's percent zero, if percent to a zero, then it's going to be a file ID. No, it's going to be a file size, and then we need to, the file ID will be I want to say it goes O, then gap, then 1, then gap. Yeah, so part 1 wasn't too bad. Part 2, my code gives the wrong answer on actual input. Oh, that's so annoying. Really annoying. That happened to me yesterday too with part 8. And I can't even remember why. I think it was something to do with maybe there was some combination of antinodes that fell on antenna that I didn't figure out. Anyway, got there in the end. Okay, so I need to. Is there an easy way to figure out if you're going to have I 0 to 4? No, hang on. Yeah, no, that's right. 0 to 4, 6, etc. It becomes ID 0, 1, 2. So it's just half, right? Yeah. So that's okay. We can do that. Haven't been able to find a logic error, and I haven't been able to find an input short enough to reasonably debug. Yeah, hugely frustrating. It's almost like they need to increase the length of some of the test inputs, but then how do you possibly generate them for everybody that kind of definitely proves all the edge cases? It'd be a monumental software engineering task. Okay, so if I sent to, does the modulus operator work the same way in Rust as it does in most languages? I should find that out. This is a file length. It does. Oh, thanks. Else, this is a free space length. Okay. That's my rudimentary and primitive approach. So someone's going to show some kind of flash iterative solution that I haven't thought of, but that's how we learn. So let's see here. We've got, we then need the ID. Let ID equals I divided by 2, correct? Unless it's 0. Let mute ID equals 0. If I does not equal 0, ID equals I divided by 2. And that's always going to be, no, yes, that is always going to be okay, I think. Yeah, because it's always going to be even, I hope. All right. Chances are that will fail in part 2, and I'll be very, very sad, but never mind. And then we want to push that ID to our vec C number of times. Oh, so it does need to be I32. Shoot. Okay, that's all right. It does need to be I32. Is it fast? Does it make any difference how? Well, it doesn't need to be I32. It could be U32. But they do need to be passed out because we need to know how many there are. So we need to know that regardless. So we may as well just do the conversion in here, I guess. Let val equals C. Is there just a pass for characters? Let's find out. Question mark. Nope. All right. Do I have to dereference it or is it not that kind of thing? No. Okay. So character passing. That is something we need to find out about. Rust character U32. Oh, I32 pass. Ba-doo. 2-digit, really? Okay. Returns an option, sure. 2-digit. Does it accept a parameter or not really? It does take an argument. What am I missing here? A is the string, A chars, C 2-digit. Oh, right, base 10. Fair enough. And this, because it's an option, same as Python, C# or Perl at least. I'm trying to finish out yesterday's part 2. Oh, nice. Co-working. I highly approve. Please don't let me distract you. Okay, so that is or else. Okay, or else. Yet couldn't pass char to int. Okay. So now for pause in 0 to val. Blocks push some, I guess, val. No, ID. Some ID. Oh, whoops. ID is a U size. How did that happen? Oh, okay. Let's just get rid of that right away. And then this will be wrong as actually I as I32. Oh, I can't do that? Really? Oh, yeah. I'm going to be doing that a lot today. I can tell. Consider changing it to be mutable. Absolutely. I agree with you. What is your problem now? Collection is never read. That's because we're about to do this. And this is, you might not need mute at all. It's more idiomatic to write let mute ID if I, oh yeah. Yeah, I'm okay with that. You can change that. Oh, that wasn't the thing I thought you were going to change. Wait, what? It's more idiomatic to write let mute ID if I does not equal 0, else O. Yeah, so why aren't you changing that for me? No, don't change that. No, don't replace it with match. Where is your suggestion from before? Anyway, if I does not equal 0, I is U32 divided by 2. Yeah. So it's an let mute ID U32 equals is that what we were looking for? Yeah. Nice. Except for this. Because it's that. All right. Now, do I actually need to type this or can it infer it? It can infer it. Nice. Okay. I think that is much cleaner. I agree. That's a good solution. Okay. So for pos and oval blocks push some ID. Yeah. Is that inclusive? I believe it is. Half open range. All values with start less than or equal to x less than end. Yeah, it does not include the end. So for a value of 2, it's going to run 0, 1. Yeah. Okay. So that's the first part of our question. The second part is what if it's free space? If it's free space, we're not going to store an ID. Excuse me. So we're going to store for pos in 0 to val, blocks push none. Yeah, that's not going to work. There we go. All right, so how could we improve that? We could what is each thing that we're talking about here? It's not a block. Actually, it is. So let's go with let mute block equals none. And block is an option U32. Therefore, block equals sum ID. Then we can get rid of this branch and do this. Like so. And now it's going to complain at me again. Oh boy. What's your problem? If else is an expression you might not need mute at all. It's more idiomatic to write let mute block if, oh, it's going to try and get me to do the same thing. I don't know, man. That's going to be a deeply nested expression. I'm not sure I agree with that. Let me block if I percent to a 0. I mean, yeah. I don't think it's a useless let if else, though. I don't know that I agree with you. This is cleaner, I think. Well, let's write it out and see what we think. That's what it's saying, essentially. Oh, right. What am I missing? All right. There we go. Do I like it better? I guess it's not horrible. Is it easier to read? I suppose it's easier to read. Oh, and this needs to be. Oh, yeah, that's right. Some idea. Yeah, okay. So, what does that actually give us? Let's debug that out and find it. Debug file blocks, and let's test it against our input. Oh boy, okay. Some O, some O. All right, where's our thing? Doop-a-doo, ba-doop-a-doo, ba-doo. Yeah, here we go. We can compare it to this. So I should have, let's see, O, O, none, none, none. Correct. One, one, one. Yep. None, none, none. Yep. Two. Yep. None, none, none. Three threes. A single none. Two fours. I think we're looking pretty good here. Let's just check the end of the sequence. Two nines. Yeah. Nice. All right. So that works. Happy about that. We can get rid of the debug and let's see what else we can do. So let's get file blocks. The next task is to move file blocks one at a time from the end of the disk to the leftmost free space block. Yeah. So the process looks like this. Blah, 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 blah. You know what would be? We should use a reverse iterator, shouldn't we? Like start from the end and work backwards to the beginning so that you get two, then two, then two, then two, then two, and so on. I guess until you hit free space. No, no, that makes no sense. I guess you just keep going until there's no more free space in the other iterator. That would be an interesting approach to try. I haven't used a reverse iterator for a while. Let's try it and see where we get to. Where do we get to? Okay, so, yeah, so let's try two iterators and see what happens. So we need another function, which is going to be let compacted. Yeah, compacted. Compacted blocks equals compact blocks file blocks, which is going to be probably a reference, I imagine. Okay, so I wonder if I could get through the rest of the stream without saying the word so again. I definitely understand why Woodstone said to do it. It must be time for another shout out too. Let's go with team. Year end. Nice. Nobody. Oh, Code Red Games is on. Nice. Sweet. Okay. So function compact blocks takes a reference to a slice of option U32, which is the blocks. Returning. Oh, we got ads in a sec. I'll probably refresh my cup of tea. Returning, what are we returning? We're probably going to just return another vec of option. I can't see any reason why we wouldn't. So met result vec option U32. And this is going to be let mute compacted vec option U32 equals vec. Okay, compacted. Okay, computer. Nice. All right, now down. Wait, what's your problem with this? This could be a const function, yeah. Down here, compacted blocks is going to be a result. So we actually need to do that. Okay, nice. So let's compact them. Well, let's compact them all. We got to compact them all. Now, two iterators, one reverse, one non-reverse. So let big for begin equals oh, there's the ads. I'm going to grab that cup of tea. Okay, now then, let's figure all this out. I'm no longer getting tea. All right, so begin. Oh, I said so again. What's wrong with me? What is wrong? Okay, begin is an iterator to blocks. It's essentially a read-only iterator. It's enumerated. Do I need to make compacted the same length? Like, do I need to reserve an identical amount of length? Because we know that we're going to need all of the space, don't we? I think we do. So if I need a Vic with whatever it is, 50,000 in it, I may as well know that up front. Blocks iter and let end equals blocks iter reverse. Yeah. You don't have to, but since you know how much you need, it performs better if you do reserve it up front. Yeah, that makes total sense. So in order to do that, I don't think I can use the vec macro, can I? Vec macro. Oh, maybe I can. Size. Oh, yes. By the looks. Oh, no, wait. Given list, given element and size. There we go. I mean, I do have to provide it an element, or can I just reserve a size? Oh, flashbang. What is going on with that? There's not even an option. What the hell, rustling orc? With exact capacity. Oh, unsafe. I don't want to mess around with that. Vec with capacity. Is recommended to use Vec with capacity something or other. At least capacity elements without reallocating. It's important to note that though the return vector has minimum capacity specified, it will have a zero length. Yeah. Interesting. Okay. Well, I've never used this before, so that's a good TIL. Vec capacity, blah, blah, blah. Vec with capacity. All right. So we ought to be able to, I assume that I can do it at runtime, but that's an interesting question. So Vec with capacity blocks length. Is it going to scarily yell at me for doing that? No. Nice. Okay. So, so again, blocks iter. Yeah. Nice. All right. So, compacted. Yeah. So I think you do while begin next. No. How do you test an iterator to see if it's gone to the end of the the thing, the container iterator at end, I guess. Peekable. I see. If you want to get the last item, convert a peekable. Hmm. Well, for that matter, next returns an option, but you don't necessarily want to call next on the one that starts from the beginning. You do want to know whether you've run out of free space to allocate because there's no point in continuing the loop after that. But you don't know if there's any free space left without either doing a filter, without either doing a find, which would be expensive, or just continuing through. So maybe we start it with well end next. Is that safe or is that an infinite loop? Oh, right. Is some. Oh, except that we need to get the result of n next. So that's why they were saying peekable. So what would it look like if we did this? This is probably wildly over-engineered, but I'm curious. Oh, but it can't be is some because one of our values is none. God damn it. Oh no, because it returns the option. So it'll return an option of an item, and the item is an option. So it'll be an option of an option. Yeah, so that's okay, I think. Oh yeah. And I imagine we'll need to make this mutable as well in order to increment it. So, all right. So while there is a next, basically, while is an element to retrieve, while is a place to go. But shouldn't it be end? Ooh. Because you want to process them all from end to beginning. Let's look at that. Okay, let's proceed on this journey there, and then see where we get to. So let ID equals I think maybe let sum ID and next. And in fact, I think we should error out if it's not, because that shouldn't happen. So I guess, okay, or else. Unexpected end of sequence, something like that. What's your problem? Oh, yeah. Oh, but no, because why is that a U32? Why isn't that an option? Oh, I see. I've got a question mark there and a question mark there. So it thinks that this, yeah, that's better. That's an option U32. In fact, it's a, um, a reference to one. So, um, else. Am I allowed to do that even though I've used the question mark operator? I think it's an else continue because we don't care if it's free space. So if it's none, we just want to go to the next one. I think that's right. So that's the start of our sequence. And then we need to decide what happens if ID is actually a thing. Ignore free space. Now, what's next? What do we actually do with the IDs? Okay, I have an ID. I'm on an ID. Therefore, I need to find the first, I need to advance the beginning iterator until I arrive at none. Which means a nested while loop, I guess, while is it possible to advance an iterator using a find? I suppose you could. It's probably just easiest to go while. While beginning. Uh, let next. Let target, I guess, equals beginning next. Would it be possible for us to, we need to check for an end condition there, right? So if target is none, that's an important thing to know about. Let sum target equals beginning next else. We've arrived at the end of sequence. So what would you do? Break. Okay. Can I make that target mutable? Apparently so. Maybe. Yeah. So then we can go while target is sum. Target equals. I feel like I'm overcomplicating this. Beginning next. How do I advance until the first non-sum value? I could do a find, but then what's the point of having a beginning iterator? I could just use an index. like to understand the iterator method. Hmm. Let's see. Rust iterator advance until condition. Oh, damn it. Iterator map can use an FN mute. In real code, I'd go for X and collision at a mute take while. Oh, take while. Ooh. Take while's a possibility. Oh, whoops. um, oh, god damn it, Rust. Where's my reference? Thank you. Creates an iterator that yields elements based on a predicate. Takes closure as an argument. Yield elements while it returns true. So what about ignore while, which is essentially what we're looking for? Discard while. I guess you could do something like do something like let ignored value equals beginning take while x is sum. Something like that. And can take while return, what does that return? After false is returned, take while's job is over and the rest of the elements are ignored. Yeah. Okay, so hmm. All right. That kind of makes a weird kind of sense to me. I don't know if there's a more efficient way of doing it, but that's the way I can think of. So now we need, oh, but wait, will it take the one that tests for none? Hang on, these are both iterators over blocks. So do I get the index for the iterator and then, oh no, I need to be writing these to compacted. And that's what's going on here. So the beginning iterator needs to be enumerated, does it not? Yeah, I think that's right. So take while will return a what? It returns a take while. So how do I use take while to get each character and write it to the other Vic? This is a good exercise in understanding. Like I could just use indexes for sure. But it would be good to understand the iterator reverse iterator thing. I always make things complicated for myself, but I do learn a lot from this shit. That's okay. We can learn. So I guess my question is, can I write to another vec at the same iterator position, like a copy iterator of some sort? Yeah. Remove an element and add it to another vec in only one iteration or without cloning. Extractive? No. What about a copy iterator? That's a thing. I know it is. It just copies one vec to another. I might need to use the AI to summarize some of the shit. Partial content from vector. Oh, this is going to be white again. Damn it. Frometer? Yep. I'm going to ask the AI to summarize some of this. See if it works. You never know. It might work today. Given an iterator over vec A, how could one write to the same position in vec B? Same positions you're iterating over in vec A. For A item, B item, and A, it is zip. Ah. And then B item equals your operation. Right. So kind of have them operating at the same time. Use enumerate if you need the index. Vec B is at least as long as vec A. Iterator zip. Interesting. Let's look that up. I think we're about to learn something. Converts the arguments to iterators and zips them. X's and Y's. Zip X's and Y's. I see. So the same iterator refers to both of them? And iter next is both 1 and 4 as a tuple. This isn't quite what I need. Because I want to write to one of them. So let's look at what its suggestion was. For A item, B item in A iter. I see. So you get a mutable reference to, right. You get a mutable reference to the other vex item in which you could use to write the thing from A. Let's just see if that actually works or if it's making shit up because I don't trust it. I wonder if I'm even allowed to, even though it's got with capacity, I wonder if I'm allowed to do it if I have to just push. Maybe I should just push, right? So take while's not going to help in this case. Oh, the Fran play. Hey, thanks very much for the raid. I appreciate it. Oh, hey, Matt Bird's Quest. You just told someone to raid me, didn't you? Thanks for the follow. That's very nice of you. Let me take care of that too. How you doing? How was your stream? Shout out the Fram play. Nice one. What were you getting up to? Hi, folks. My name's Basie. I do like Rust and Bevy, and at the moment we're working on Advent of Code. We're only about 8 days behind everybody else, but that's fine. Everything's fine. It's fine. It's going to be fine. In theory. Third year of game dev study. Very nice. You know, a quick week-long game in GameMaker. Very cool. I'm not a GameMaker person myself, but I know many who are, and they speak very highly of it. Productive, making a 2D game called New Jersey Takedown about taking down drones in New Jersey. Nice. Very topical. I like it. Very topical. Yeah. Affiliate. Nice. So cool. You are a game dev, and therefore, you might be interested in my stream team. Well, it's not my stream team, but it's the stream team I'm in. Let me see. This one. I will silence that. And we will paste this. And we have a very friendly Discord, and we talk about a bunch of stuff about streaming, game dev, and software, and so on. And there's all these people on at the moment. But yeah, the person to talk to is Falinair, who's not online at the moment. And there is an application link on that page if you're interested. I highly recommend it because it's a bunch of them. I have a little macro that shouts out some of them, and there they all are. Oh, and I'm timed out, so I can't shout out. But yeah, you should hit them up because good peoples, very good peoples. Right. So, where were we? It is zip. So the thing is, I want to go until I have written a thing, basically. So I need, I need to zip my etters. I need to zip etters. I'm not going to enumerate them. I met another game dev streamer. Glad I'm getting more involved on Night of Love. Absolutely. Whereabouts are you studying game dev? Zip, it was what? B mute. So that effectively would be compacted mute, like so. Nice, no errors. We like it when there's no errors. We would do, I was really only there to look. Raid and run, but you're hungry? Totally. Go and take care of yourselves if you need to. 100%. I appreciate you stopping in to witness my pain. Okay. So this is no longer advance the other iterator until we arrive at none. I need to go while. So that's while in peak is some. I want to advance the beginning iterator until by the same conditions, basically. I am also from New Zealand. Third semester, intro to game design and network. Nice. I've never actually studied game dev. I've just kind of picked it up last year and tried. But I have done software-y things for a long time, so it's just a bit of a change in subject matter, I suppose. Third semester, well, you're even starting out a little earlier. Very cool. Uh, what I need to know is it's gone for a. Oh, I see. So you could just use a for loop to go through it. So let's go for. So is it going to return both items? I think it is. It's going to return for block, and I guess C block, which is a terrible name, but we'll live with it for now. In big for begin. If block is none, technically this is your third year, returning student, dropped out to go to work and then came back to college last year in January. Nice. Well, good on you for cracking back into it. Should be very interesting. I imagine they'll be doing mostly either, well, it depends what they're using, I suppose. If they're using GameMaker, I imagine they might end up using Unreal or Unity. So you'll be either in C# or C++. If block is none, then we want to write to C block. Ah, I see. So we choose which iterator to write from. So basically we either write C block or compact might be a better name. Equals if block is none, it's going to equal learning blueprints in C++ and UE5. Nice. Use GameMaker to make something simple and get started with streaming some small projects. It's very wise because Unreal can be such a huge topic, I'm sure. And C++ can be quite daunting if you've never written it, or even if you have. So, yeah, absolutely. Doing a bit of GameMaker must be like a breath of fresh air. If block is none, then we're going to write the contents of end, I think. Yes, we're going to write ID. Otherwise, we're going to write, what's the other thing? The other option, just the thing from begin, so that we gradually copy everything across. Now that is going to cause all kinds of errors. I'm 100% certain. Yep. Okay, so I was expecting an option and it found a reference. That is absolutely true. So we want to go. So actually, there's no reason for us to extract this, I guess. Oh no, because we have to ignore free space. So we need to find out what it is. So let's go sum ID. And now it'll tell me I need to dereference. Yeah. What am I working on? I don't know if you've come across Advent of Code, but it's a massive time sink. I'm just warning you up front. But it's an exercise that runs every year, and this year is the 10th anniversary of it. Where a bunch of coders get together, and I don't know if you know what an advent calendar is, but it's something where you open a new thing every day of Christmas until the 25th. So in this case, it's a new code exercise. And some people try to speedrun it, but I just try and work it out. A lot of people try and use it to learn a new language or just experiment or learn about a new library or whatever. So you work on these puzzles and then you get an input for them and solve your solution. And yeah, it's kind of fun. And this one is a simulated disk defragmenter. So we're trying to take all of the free space in a file and move all these bits, all these blocks across to the beginning so that it compacts them all uh, in a very manual way. Okay, so this needs to be some begin, I think, maybe? No, I'm wrong. Oh, right. So that's a zip and it can't be dereferenced. The type constructed contains standard editor zip option U32 due to the type of argument passed. Right. So it's got two things. I see. I need block. Actually, just block like that. Dereference. I will always mistake that. Moved value. Okay. Now we're getting fun. Do I have to go cloned or copied? Definitely not. It sounds awesome. I'm still a new programmer. I can read it and understand it, but I have a hard time remembering things. Practice is 100% the thing. You're absolutely right. That's all it is, really. It's just time spent. It's not that you don't understand something, you just don't understand it yet. Okay, I am kind of at the point where I may need to enlist some help from the AI again because I don't quite understand. So move occurs because beg has type iter, which does not implement the copy tree. So can I make it a copied or cloned, maybe? Ooh, this looks promising. Nope, same problem. Damn it. The implicit call of into iter in previous iteration of loop. Really? So copied doesn't help me. just guessing at this point, which is never a good approach. Okay. I think I need to take a swing at asking for some feedback and seeing if it understands my issue. Got to head to sleep, got to work in 6 hours. Oh no, yes, you should. I hope to learn some new stuff from you. Thank you so much. Feel free to ask questions in our Discord if you feel like it. But nice to see you and have a good rest. Okay, so given the following, suggest a reason, suggest an approach to overcoming the moved within loop issue. See if it understands that. I'll pre-initialize it with none. Remove the zip and used enumerate. Yeah, I don't want to do that though. I want to understand that. Assume that we'd like to use iterators rather than indices. Is there a way? Recreate the iterator for compacted in each loop iteration? Oh, damn. Really? Oh, that seems bad. That seems very, very bad. Cloned or copied iterators can't help us here. Only if you've got an initialized. Hmm. So let's play around with a couple of these options, but I'm not hopeful. Not all that hopeful. That yields that, but it yields option U32, option U32, expected reference. Why did you expect that? Found tuple required for clone zipped. I see. So you can't clone a zipped iterator. Is that what you're saying? And I take it you can't copy it. Hmm. Might be unreasonable to expect to be able to copy that, given that you've already defined it as a zip. So the issue is that, oh, hang on. The issue is that we've moved it, right? Use of moved value. What a shame. I wonder if we could turn it on its head. Like we could put this loop. We might strike the same problem, but let's try it. Let us try it. So we're saying we want to iterate through block by block. And we want to wait until it's if block is none. We want to look for the first available thing in the reverse iterator. For I don't know, end block. uh, for end block in end. Are we already running into trouble? Yes. Yep, same problem. So how do you deal with, due to the implicit call to enter iter in previous iteration of the loop? How do you deal with nested iterators? Can you just not do it? Maybe you can't. Maybe you can't do it. Maybe I'm backing up the wrong tree. Just seems like it ought to be possible. Rust nested iterators moved. Set two iterators and a callback and process as follows. Yeah, exactly. Why do I struggle with this? You can request the iterator to be clone is better than copy, and iterating over clone is more types implement clone. When you run a for loop, the iterable argument you pass is moved into the for loop. Most iterators you encounter in Rust are cheaply clonable. All right, let's try it. Oh yeah, this might not need to be peekable anymore. Interesting. Okay. Well, let's proceed down this path. I'm curious now. Why is it end clone and not end cloned? I wonder what the difference is. Maybe we're cloning the iterator itself. Yeah, and not the thing that it points to. Interesting. In that case, could I have done that with the previous one? Let's find out. Well, no, this is fine. Okay, so um, if end block is some or is none. Should I test for the nuns first? Continue. And this could be a take until as well. I don't even know. Um, okay, so if end block is none, continue, and then compact equals some. Actually, compact equals end block. This feels like an unnecessary loop somehow. Oh, no, that's right. Well, I don't know if it's the most efficient way of doing it. Compact equals end block break. This feels like a function rather than a for loop. Okay, well, at least we're not lighting up with red. Continue. And then the last part is just compact equals block. Interesting. Okay, well, that was a very interesting journey into iterators. I'll look at how I could make this better in a sec, but let's see what its output is so that we know whether we're completely backing up the wrong tree or not. Debug compacted blocks. It's like our tests have actually died. Okay, compacted blocks is empty. That's always good to know. I think that's because of the vec with capacity. Instead of writing directly to it, I should have pushed. In which case, I don't need a zipped iterator. Very interesting, though. For block and begin. And then we go compacted, push, block, and block. Oh, not block. This one is end block. Hey, we got something happening. I should see a bunch of nuns at the end if this has worked. Oh no, because I don't do that, right? So, um, all right. If end block is none, continue. Yep. If block is none, yeah. Compacted push block is the alternative. So if block is none, we push the thing. We shouldn't just have a continue here. We should only have a continue if we've run out of end blocks, basically. Um, so this for loop should go all the way through, but this break will only get us to here. And that's not good. So this design is a bit wonky. I actually think what we might need is the other way. How do I tell when to stop? Basically, when we've run out of, I need to test to see whether end has finished or not. If end block is none, continue, else, yeah, so that just gets you to the next iteration of this loop. Too many nests. um, if block is none, I think we really need to answer the question, is there anything left in, so this really needs to be a function. So let's go with, can I pass the iterator to a function without the lifetime? We're gonna have some ads in a minute. Fn get next block, something like that. So I want to pass it an iterator. What is end? It won't tell me. It's a reverse iterator. I don't know how to pass that to something, or even if I can. Rev passes a, why haven't I got any information available? Weird. It's an iterator over a, well, it'll tell me if I pass it the wrong thing, right? So let's just say it's a back option. And it should return a option U32 for block in it. Might need to be cloned. Or I could just pass it cloned, I guess. If block is none, continue else return some block. How does this help me? Wait, what's going on here? Oh, expected U32, right. Okay, that won't have helped yet. So if we go, it's always going to return the next available block. But if you've advanced the iterator past the point where there are any more, then you should just return. You should just return none, right? I'm not sure if I've got that right. Let b equals get next block end clone, and it'll tell me exactly what's wrong with that. So many things. Yeah, here we go. Rev iter option U32. Okay. Can I pass that to a function? I don't even know. Oh, that's our lifetime specifier. I have no idea if I'm getting this even close to right. Oh, so this isn't a thing? Standard iter rev? We're well and truly down the rabbit hole now. Standard collections linked list. Result, slice. Which one do I want? Oh boy. I genuinely don't know. Can I pass a Rust iterator to a function? Generics. Oh. Oh, iterator rather than iter? I see. So then you do have to use generics. Okay. Lifetime A. Something that takes into iterator. We're well and truly down the rabbit hole now. So we're going to go. We might want to elide that, but let's just figure it out. Where? Option U32. So much badness. So much. Right. So we're definitely not there yet. Actually, it's an iterator over vec, right? Which trait needs to be in scope? I think this is definitely wrong. How could I use the same logic that's in the function? Oh, wait. I'm in the wrong function anyway. God damn it. Okay. Undo, 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 undo. Many undos. So many undos. Wow. I'm really losing the plot now. That's okay. Okay. So this needs to take. Whoops. Ah, there we go. It needs to take where I a comma I where I, yeah, this thing. And its item. Now there's a lifetime specified there, but I don't know that I need it. Do I need it? I don't think I need it. It's just tray without it. Iterator over a vec option U32. I've gone one too far, haven't I? Okay, now we've got a different kind of problem. Expected standard option U32. Required by bound, blah, blah, blah. No method is none for vec standard option. Right. I see. So it thinks that the iterator is over a vec option U32, which it should be, but it's also a reverse iterator. To be an iterator that yields vec option U32, but it yields address of option U32. I see. I see, I see, I see. Hang on. Figure it out. You can do it. Option U32 can't be dereferenced. Expected reverse iterator to be an iterator, but it yields address of option. Interesting. Hmm. So there's still this one problem. Oh, like that? Ah, you do need a lifetime. So do I need to do it here? Like so? Wow. Well, that's a more complex function than I've written in a while. Interesting. I see that we're copying nines everywhere. Okay, cool. So what are we actually doing? For block and begin, let b equals get next block end clone. By the way, can we do it without cloning? That would be a no. Okay. So we're cloning on every single iteration, which feels like a bad idea. But you know what? Let's roll with it. And push B. So it's always pushing 9. It's never advancing it. Yeah, end is always 9. Yeah. Okay. If it wasn't, then yeah, it's not advancing the original iterator, it's just advancing a clone of it. So it never changes. This doesn't actually help us, but it's really interesting. So I think I might comment it out and we'll just go back to trying to implement it in this loop. I'm going to resort to just using indices any second now, but I'm just curious. I'd like to just ride this as far as we can. All right. We'll block and begin. If block is none, then we've got a space. If, actually, let's do it the other way around. If block is sum, or if let's, if block is sum, compacted push block, because it's just an easy copy, right? And continue. If it's not, then we look for a candidate. Look for a candidate block from the end of disk. Now, do I use a for loop to do that? Or I guess I do, right? For end block in end. If end block is sum. Compacted push block. and then you would break. Okay, all right. This is actually kind of okay, I guess. Uh, dereference and dereference. And now we've moved it. Okay, so this has to be a clone. Oh, okay. So now we've got a situation where we're just not modifying anything. We've created a copy. Block is a reference to option 32, U32. If in block is sum, compactor push block. So is this ever happening? Okay, well, apparently so. But not in the right spot. So if block is sum, compactor push block. If in block is sum, the thing is it's always going to clone the end. It's always going to start from the end. Let's display the actual block we're looking at. Okay, well, that's not what I expected. What about is sum? Block is none. Oh, I see. That's what's going on. Naming sucks. Hey, I think this might have worked. Hang on. Okay, so it hasn't quite worked, but this is interesting. So, um, it's correct in that it's filled up the space with the nines. But the difficulty is that we never advance it. So it just uses 9 forever. We've invented a new character for the empty space. That is not what we want. We want next. But I can't use next because I'm moving it. Is that what have I understood that correctly? Like I can't modify end here. So I don't think this is useful to me. But it's interesting. How do I do this? I think I have to use an integer, right? An index. I can't really see a way around it. Something from editors probably encompasses this exact problem. How do you do iterators from opposite ends of the same? See if that's a thing. Rust iterators, opposite ends of container. Hmm. Combinations, dedupe, blah, blah, final first. Uh, both reverse iterator and normal iterator. The search is tricky. Uh, Definitely a question that I want to ask someone. Um, because I want to keep advancing end until it gets to beginning, but I can't because I'm moving it. What if I go back to the while loop? Essentially, while end next. This is never going to work. I'm just curious. Is sorted. Okay. The struct standard editor rev. So how do I get the thing? Right. So you can't dereference it. And I can't do while in next, apparently. Expected bool. So it would have to be as sum. But n next is the thing that returns the item, right? Returns none when iteration is finished. So I can't do a while loop based on that, right? Is there an equivalent to the, I guess, pattern that also makes the value pointed to by the iterator available? Oh, while let. Oh, nice. All right, let's see. Let's see if that works. Um, I should have guessed that was available. Well, let's block equals end next. So I can't do this. For space, I guess, in bag if space is some compacted push block. Of course, this does not use the iterators the way they should be because you kind of also want this. So if it's none, then you want the block. Okay, so not good stuff. Could be written as a for loop, yeah. But it doesn't advance the iterators. If space is sum, then we just copy the value, which is fine. Oh, this should be compacted push space. And that's obviously wrong. It's almost like an address, this, or cylinder or something. I don't know. If it is some, otherwise we push block. So if it is some, then we just copy the space. So say we're on 9, which is at the end of the string. Actually, it's here, right? So where is this coming from? Oh, I think I misunderstood something. I was expecting the 9s. This input is not what I was expecting to see. I was expecting this. Right, because this is what gets generated from the input. I understand. Okay. So yes, you do get 9s at the end. And it should end up with 0099811. So obviously that's not what's happening. 888111. Where are the 9s even? They're still right at the end. Okay. So while it's some block end next, while it's some space beginning next, if space is some, we also need to break here, I think is the problem. Compactor push block. Yeah. So we wait until we get to an empty space and then we break out of it. And now we're in big trouble. But we still got O's, eights, ones, sevens, twos. And the nines are still at the end. Yeah. Um, the difference, the final difference is if we get to a point in beginning where there are no more blocks to write from the end. I actually think this belongs the other way around. What's the problem, by the way? Never actually loops. Okay. Okay, so what happens if we do it the other way around? If space is sum, push space, and then break, or continue actually. Otherwise, we try to get something from the end. Well, that sum block is end next. If block is sum, imagine how much faster it would have been to just use indices. Compacted, push block, and then break. That already gets the nines in there, which is encouraging, or two of them at least. What should it be? 0099811. 0099811. Ooh, it's starting to work. It's starting to work, kind of, except for this. Compacted push block. Yep. This is going to say it should be a for loop. Yeah. Break. And what if it's none? Down here, we have to push a none. We want a bunch of nuns at the end, but we're not getting them. Okay. Will block and end by ref. Oh, that's interesting. So if there's a block, and this is obviously working at the here at the start. Oh, except it's not right there. If block is sum, compacted push block, continue. Oh, continue will work anyway. Won't it? It obviously hasn't. It obviously has not. So we break out of there, and that gets us back to here. Oh, and then it pushes a none. So that's obviously not good. We need an else in here somewhere. And we continue there. And then we search through to find the next value that it isn't a none. And how do we handle the case where we need to write a none? Like if we've just run out of space to reallocate. Space is sum, sure. Then we loop. Gradually, we'll end up at a place where we've run out of free space, right? Oh, I think I've discovered the issue. Oh, hey, June RC, how you doing? Thanks so much for the red. I appreciate that. Everybody probably is already following June RC, but if not, you should. How was your stream? What did you get up to? Hey, everybody, I'm struggling through Advent of Code. I'm very slow. It's painful. Hey, how you doing? Um, I haven't seen you in a long time. That's right. In fact, you've never talked in this chat. Oh no, that's a Raider thing. We were playing Coral Island. Oh, I do not know this game. Oh, okay. It sounds like a farm sim kind of game, which is pretty cool. Looks really hard. Well, maybe yes. I'm trying to learn about iterators, and it's not going very well. I know how to solve the problem another way, but I want to solve it this way. So, farm sim, it's kind of my obsession. Not going to lie, I understand completely. I have spent ill spent hours on ridiculous things like Stardew Valley. I understand. Okay, so if block is compared to push block, so we need to deal with the idea of when we exit, right? So, and also we're not. The problem is we're just pushing to the other vec. We have no way of knowing when to stop, basically. And also, you'll eventually start recopying the values the further through you get. Oh, yeah, this sucks. This is not the way to do it. The only way to do it would be if you were totally, please lurk, take care of yourself, and go do whatever you need to do. Thank you so much for bringing your viewers in. I appreciate it. Okay, so this probably doesn't make a lot of sense, right? It's a nice idea, but it probably doesn't make a lot of sense because eventually the beginning iterator gets to the point where it's starting to copy the stuff from the end iterator. So should I actually stop once I get to a certain point, or should I just throw it? We need to tell it to ignore. We need to tell it to ignore end once it gets to a certain point. Hmm. Should I just bail? Or should I really try and finish this bit? Honestly, don't know what to do. I'm trying to understand if I can take iterators from the opposite ends of the VAC and just march them towards each other till we get to the point where they meet. And then we're basically done, right? Because we can't move any more things. If and is less than, can you compare iterators like that, or is that ridiculous? Begin, break. That's silly, right? Yeah. Um, checked if Rust iterator less than. Yeah, that's silly. Okay, I think I have to bail and do it another way. It was really interesting, but I just don't quite think I had the right idea. So we're going to have to use indices. Um, let's see if we can do it a more normal way. Because I think this is just a fool's errand. For I space in beginning. Actually, let's just go in blocks. Um, if we've got to move from the end, but that's okay. That's okay. If I wonder, we may still need the reverse iterator. We'll see. We'll see if we need it. For iSpace and blocks, actually, let's get rid of that. And then if space is sum, compacted push space. Continue. Oh, that needs to be enumerate. Okay, so already we're copying all of the sums. So that's good, but they're not reordered, that's for sure. So otherwise, we need to go from the end of the, we need to search from the end of the, we could just reverse the whole thing, I suppose. But we've got a reverse iterator, so shouldn't we be able to use that? Let foo equals end take until, take while. Be block, I guess. Block is none. So I can't do that. Oh, again, because we've moved. All right, so what happens if we just clone the damn thing? let copy equals blocks cloned. I don't know, blocks 2. I'll figure that one out. So just clone the whole damn thing. So same problem. Oh no, that should be blocks. So even though it's a clone, I still can't refer to it. Damn. I can do a clone if I want to start from the end each time, but I don't want to do that. So I have to use I can't use a reverse iterator. I have to use an index. Let end index equals, or even just j. I'll let end equals blocks length -1. While end is greater than 0. Yeah, greater than or equal to 0. And yeah, if blocks end is some compacted push blocks end break and decrement it. So and minus equals 1. What? All right. Wait, what? Oh, I see. Wow, I'm really starting to get brain fog. Type limits. Oh, it's a use size, right? So and minus equals 1 break, and then and minus equals 1. All right. There's bound to be a way to use reverse iterators here. I just don't know what it is. Okay, so this one, by the way, has completely failed. So let's go again. Okay, so now we're getting O's, 9's, 8, 1. That is correct, but this won't be. Yeah. So that's great. We need to know when to stop. It's the same problem. Push space, continue. And we only do this while the end is not 0. So the final step is to push none. Isn't it? Nope. N minus 1 while n does not equal 0. Do I also need to test for the value of end? Otherwise, we're done, right? Nope. Doesn't help. Um, if blocks end is sum, blocks end, which is a option U32, and then break. Oh yeah, that will absolutely, yeah. So then continue. Nine, eight, ones. Still not pushing the nuns at the end. Damn it. Because the trouble is, it will eventually get to. Shit. This is way harder than it seems. How long do people take on this one, I wonder? I'm sure there's a simple approach to it. I just have no idea what it is. Trouble is, if space is sum, yeah, we have to exit early if we've reached the end. But that means we actually need two. Yeah, we need to. Yeah, we can't use this. Man. While beginning does not equal. While beginning is less than. This is going to say it should be a loop again, but we're going to advance it, I think. I don't know. I'm so lost. I'm just going to try. So while begin is less than block's length, and it's going to say you can use a for loop for this. If end is 0, then we don't break. But we could effectively write a bunch of nuns. I think that's. We need to use all the available space. This is really sad that this is giving me so much trouble. Okay. While begin is less than block's length. Should it in fact be while begin is less than end? No, it's always less than end. If we always want to write to, I suppose the other way of doing it would be to write, to overwrite. This could be a mutable iterator. To set the thing that we've moved to none. And then, hang on. Let's go back a step. Yeah. So can we pass a mutable reference? So we need a lifetime. All right. So instead of doing that, can we iterate over a copy of it? Hmm. Is it clone or copy? All right. So now when we do this, we're going to go We're actually going to go over cloned. Oh, so what am I actually supposed to be doing? You know what? Instead of doing this, why don't we just do... But I don't care about the result. I don't care about the original one. So how do I copy it? Copies all elements from source into self using a mem copy. Oh, really? Okay. So what is cloned now? It's an array. I don't want it to be an array. Okay. Now, compacted, sure. Compacted, push. So I bet we could end up using the reverse iterator again now that we understand a bit more about it. But anyway, compacted push, cloned, and I am so looking forward to seeing other people's solutions to this. I'm going to be kicking myself. Oh God, here we go again. Where is it borrowed as immutable? Oh, there. I'm not trying to borrow it as immutable. I don't think. Ah, it's painful. I've got 2 pointers tracking through an array, I and end. I can't write to it. So what if I were to say, What if I were to use blocks here? And cloned here. Same problem. Oh, pain. Think about it. I've got 2 copies, but I can't borrow it. I thought that I had obtained a mutable copy that I could do whatever I want to, but apparently not. So this borrows it as immutable. Can I do cloned here? Kind of, but also not. So no. Copied? Same problem. You can't do it at the same time. See if the AI can translate some of this for me. So I really do not understand what the idea is. How would one avoid borrowing as immutable and mutable at the same time here? Hopefully it can ignore the comments. Work entirely with cloned after the initial copy. But that's what I was doing. I'm reasonably confident that won't work, but I'm willing to try it. Yep, same problem. This function exhibits exactly the same problem. Work with indices or splitting the work. Exactly. See, this is what I was trying to do with, I'm not going to look at the solution, but that's what I was trying to do before. And then I decided, oh, actually, maybe I don't need to. Okay. We have a mutable clone. Let's undo all of this. So we had essentially begin and end. Uh, while begin is less than blocks, sure, cloned length. If begin cloned begin is some, push cloned begin, and continue. And then, while end is not 0, subtract 1 from end. If block's end is sum, well, we can go cloned, I assume. Compactor push block's end. I'll see now it's just source slash length does not match destination slash length. Okay. And I can't clone it because it's a reference to a slice. Can I just pass a mutable reference to a vec? Because this is driving me nuts. Throw all thoughts of immutability out the window. Along with any reputation I might have ever had as a computer scientist. Oh, God. Okay, so we need to go back down to the tests just to correct this. File blocks is get file blocks, which is a what? A vec option U32. So we need and mute. Cannot mutate a mutable variable. Blah, blah, blah. Involves a new object where a slice will do. Okay. Now what's happening? Oh, God. Loop. Stop. Oh, God. Shit. Okay. Yeah, we need to increment. Oh, man, it's still running some. It will be called AOC something or other. Yep, there it is. No such process. Okay. Okay, baby. I have to go in 30 minutes. Various things using memory, but nothing too bad. Okay, I think we're done. I think we're good. I hope we're good. Okay, infinite loop. That's the characteristic of advent of code. So, okay, don't run the test yet. Where are the other places this can loop? Compacted push bag plus equals 1. Compacted push blocks end equals none. And increment there. If n does not equal 0, continue. That shouldn't be necessary, right? Oh, hang on. Let's think about this. There are more potential candidates for uh, defrag. Big plus equals 1. Now hang on, because we've broken here. Hmm. And the final step would be push a none. What's the problem? This can't possibly be the most efficient way of doing it. Okay, I think I've covered all the loops anyway. Let's find out. Okay. No. So that's wrong. Um, if the end is 0, do we ever get to this point? No, we do not. Okay, so if blocks begin is sum, push a block, add 1, and continue. If end isn't 0, subtract 1. If block's end is sum, push it into compacted, turn it off, and break, which leads us here. If end is not 0, there are more candidates. Let's continue. And we never get to this point. So it must exit out by just using those. I feel like we should be doing this the other way around. Got to be careful not to loop again. uh, so let's quit out of here just in case. Okay, so if it's none, look for a candidate for replacing it. Break. And then that only happens if the block was none. Otherwise, we push whatever we find. It's probably a recursive solution or something that I'm missing here. If n does not equal 0, there are more candidates for defrag. Begin plus equals 1, continue. Otherwise, but why do we need to do this? Why can't we just omit that entirely? Because otherwise we'll push whatever's in the beginning block. Right. So we've broken out of there. We're still in the case where yeah, this is why I think it might be better as a recursive solution. We're still in the case where the block is none, so we've had to fill it up. But we don't want to also do this. Okay, let's try that again. Those initially look right, but we need nuns at the end and we're not getting them. Okay. In theory, it should push these, the ones that are written. But it doesn't seem to be. This isn't a reference, is it? No. Break. So can I... Why isn't it writing the nuns? Well, it writes the nuns in between then. So advance. Well, begin is less than block's length. If it's none, then we do some shit. Otherwise, we push the block that we're on and we increase. If the thing we find is sum, then we push it. Otherwise, oh, because if it finds it and it's none, it will never push. Right. Okay. But wait, why wouldn't it just skip right through here and push the none? It should do it until... it gets to the end, but it doesn't seem to. I have 20 minutes before I have to stop. This is really frustrating. I'll probably solve it in the shower. More potential candidate. So we subtract one. Maybe if I just output what end and beginning I'm pointing to. Oh, end never gets to 0? Oh. Well, that could explain some things. Right. End never gets to 0. Wow. And also, what does blocks look like at the start? It has some nuns in it, doesn't it? Because that would really suck. Yeah, it definitely does. There aren't any for a little while, but you get to one around, yeah, another 42 of them. I guess so. So, given that, why we subtract one each time, we keep going down, we get 42. Let's try outputting a marker every time we hit none. So at beginning 2, we hit our first none. The empty space. Does that tally with what we know about this? So file space. Yeah, that does, because yeah, the file takes up the first two slots. And then end is subtracted by 1. The block is sum, so it should push the 9, which it does. We know that. Then it changes block's end to none, and it breaks. Then it checks to see if it's not already 0. It increments beginning, and it continues. I don't see the problem. It's so strange. I think I've been staring at it for too long. I mean, it's finding the bits where it needs to replace a value. And it should only do something else if end is not 0. It should loop through until end is 0, and then it should just write out the line. Oh, but it doesn't push if it's none. Oh, god damn it. No. Fuck you. Why? Let's look at where the pattern breaks down. It should be up until we get to 4 5s and 2 6s, and the rest should be empty. 1, 2, 3, 4, 5, 6. There. That's where it's broken. It's like it's just a nun remover. It removes all the nuns. It doesn't add any of them back. So it never pushes this because of this. That's definitely not the way. Shit. What is going on? Why can't I understand this? I will definitely remember this, that's for sure. I assume we never get to this point. And I assume correctly. Why? We do this part while n does not equal 0. Definitely not. Because of this break. We're basically saying if it's none, give me an opportunity to replace it with something from the end. If we find something from the end, grab it, and then break after writing none. To wherever the pointer was for that one. So we increment over it, but if we do that, then we increment past all of them at the end of the sequence, which we don't want to do. So should we just have stopped going once beginning has become greater than end? Because we can't have any more opportunities. Because the trouble is, end will just go straight past all of its nuns until it hits a sum, even if it's on index 1 or whatever. There's something about this puzzle that just doesn't fit in my head for some reason. I don't know what it is, but it's tremendously frustrating. I mean, I could just use recurrent find just to solve it. It's just frustrating. I want to be able to do it from either direction. I can't look up the answer now because it's just going to be total defeat. So I need to figure it out. But it's a bit sad. It's like we need to remove the item from the end. We need to pop items off the end of the vector until there's none left, basically. If the iterator over the reversed one is on a different copy of the vec, does that help us? I mean, what if we just reverse the other vector, reverse the vector, remove all of the, that actually kind of works, although it's probably expensive. is a mutable slice to an option U32. Can I clone that? Hang on. I think I'm sniffing something. I'm sniffing something. It's probably bullshit. Compacted equals blocks. Clone. Just out of curiosity, is going to complain at me. Hang on. Let's figure this out first. Compacted filter. It's probably a more efficient way of doing that. Right. So how do you extract everything? It's called um, I think it's like okay. Hmm. It's like map ref, or there's a thing that you can use. Map okay turns into a rate adapter that applies the provided closure to every result okay value. No, that's not it. Um, let's ask it to summarize. Get vec of U32 from vec option U32. Filter map. That's what I was thinking of. Right. That's what it was. Okay, so that's all the non-empty values. And we also want to reverse it. So I think it's just, isn't it just compacted reverse or something stupid like that? That'll be hugely expensive, I imagine, but let's do it anyway. Let I equals 0. Okay. Let's see if we can knock this out. Okay, so the block in blocks. If block is none, block equals compacted I plus equals 1. And then we're probably not even going to return the vac because we shouldn't need to. Right, so block will be sum. And now this, okay. So now the final step is this doesn't help me. By the way, why is it complaining about that? Oh, I could have flattened. All right. So the idea was nice, but it doesn't help me because I'm modifying in place. And I still need to know which ones have been moved, which means I need an index. God damn it. So this is essentially rewriting the program again. In yet another way. Pain. Total pain. Okay. Well, I don't think I'm going to get it. It's ridiculous. Definitely shouldn't try and do this stuff while I'm fasting. The brain just switches off. But I definitely thought I would have approached a solution before now. So we've got it reversed. I suppose I could use the reversed ones like, okay, so if it's none, then you need to check. Oh, it's equivalent to edamute. Okay. But you would need to check. You need to advance forward through compacted until you get to a non-none value. Nah, screw it. I'm not going to get it tonight. I just have to come back again. Thanks for lurking.